Omaleje Fijojo, celebrity mathematician. Today, we're looking at second logic class. Let me put it like that. Last time some people were asking, is this for mathematics or English or this and that? You are going to see the second class of that very logic. Now we said that the other time we said that logic is the process of reasoning out the relationship or connections which exists among collection of facts. Collection of facts. So in this very class, we are going to look at the law of excluded middle and a little talk on included middle. We have the law of excluded middle. Excluded middle. This has to do with classical logic, and the notable person there is Aristotle. Then we have the law of included middle. Included middle. And this has to do with Stephanie Lupasco. So in this law of excluded middle, we'll look at what they say, that is tatium non-dator. Tatium non-dator. This means there's no option for third. There's no third option. There is no third option. That means it must be two, no third option. It's either false or true. Is that you are a woman or a man, heaven or hellfire. So it must be two things, no third option. That is what Aristotle brought. But these people, if we're looking at artificial intelligence now, the natural frame of reference, some people say you exist before you came to this place and you are going to heaven or hell. Then we're talking of the law of included middle. And that has to do with quantum mechanics. Don't bother. Logic will increase your reasoning. So coming to this very place, we mentioned simple statements. We also talk about compound statement. We say simple statement is a statement that cannot be separated into two. We say that compound statement is a statement that is made by joining or combining two or more simple statements. But we are going straight to what we call today conjunction. And we say that the symbol is this. The other time, conjunction is a compound statement that is formed by the connector or connective and by connective and. I'll say that any statement that is formed like that, we'll call it a conjunctive statement. Now, the truth table for this, what is truth table? Truth table is how truth or falsity, the statement that is made by combining one or two simple statements, is true or false. So the truth table for this and, assuming we're having a statement, we say simple statement is a statement formed by just a single phase and cannot be separated into two. But in this case, it's a compound statement. Conjunction is a compound statement. If you have first statement P, second statement is Q. We said the other time that Jane is married and her mother is happy. That means the first statement can be P, Jane is married. Second statement is Q, her mother is happy. So what to join these two statements is and. So we said Jane is married and her mother is happy. So that is what we are using here. So for example, we're having P, Q. So the symbol for this, or let me say the formula for this, that is operation, is P and Q. So when this is true, Jane is married and her mother is happy, then this is true. The statement is true. She's married and her mother is happy. What we do to this, we say that in this case, our T is equal to 1. Our F is equal to 0. Good. Then 1 times 1 is equal to true. Jane is married and her mother is happy. Secondly, what if this is true? Jane is married and this is false. So Jane is married and her mother is not happy. Is it true? Now let's check it from the calculation of multiplication. So we'll have that this is what? 1, so our T is 1, F is 0. So 1 times 0 is 0. And our 0 is what? F. That means it's not true that Jane is married and her mother is not happy. If Jane is married, her mother should be happy. Okay. Then we'll now have, what if this is false and this is true? That Jane is not married and her mother is happy. Is it true? That is 0 times 1, which is 0. If Jane is not married, you don't expect the mother to be happy. So this is false. Then what if this is false and this is false? Jane is not married and her mother is not happy. We said 0 times 0 is equal to what? 0. Jane is not married and her mother is not happy. So, is false or true? In mathematics, this is what? False, because we are using a calculation. And in this case, the operation of this is times. That is Q times, that is P times Q. Sorry, P times Q. So this is what we use in this operation, in and here. Take notes. So we'll move to what we call, or injunction. 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 In this case, we said it's like this. Remember, now what do we do here? In injunction, the operation is what? The operation is P plus Q. This is operation. Then we'll have P, we'll have Q. I know that you know what we are going to do here. Good. Then this is P. We have already known the symbol for this. The symbol is what? The symbol for this is this. Q. Right? Now, what do we do in this case? We have this. We have this. Statement can that be true or false? Now, this is true. This is true, and this should be true. Remember, that is, in this case, the same way, our T is equal to 1 and F is equal to 0. So 1 times 1 is 1. 1 plus 1 is what? 1. Because we said that the operation here is what? Plus. Now, in this case, some people will say that why is 1 plus 1 not 2? No, this one obeys the law of marriage. 1 plus 1 is equal to 1. We are one forever. That is celebrity mathematician talking to you. And in binary operation too, 1 plus 1 is what? 0, because you carry 1. Because the highest number you can see in that place is 1. You cannot see 2. So this obeys strictly the law of marriage. 1 plus 1 is equal to, if you have not yet married, this year you will marry. And we'll sing for you, 1 plus 1 is equal to 1. We are one forever. So this is logic, man. So in this case, 1 plus 1 is 1. And we say our 1 is t. What if this is true and this is false? That is 1 plus 0 is equal to what? 1. That means this is true. See, this one is either Comrade Elvis Onoha will visit us or call us. So it's either he visits us or he calls us. So it must be true. Either of them will come to pass. So it's true. So then we'll see, what if this is false and this is true? What do we have? That is 0 plus 1, which is equal to what? 1. That means we say that either Comrade Elvis will call us or he will visit us. So either of them will come to pass. Remember, we are using or in inclusive sense. So it's either he did not call us, but he visit us. So the answer is what? 1, which is true. What if we have this is false and this is false? That is 0 plus 0 equal to what? 0. That means in this case, it's what? False. He did not call us, he did not visit us. Is it true? No. We say either. That means it's either he has called us or he has visited us. You can't say that he did not call us and he did not visit us. So it's false. Thank you so much on this area. So we now move to what we call, there's another one we call by implication. An implication. But we'll start with implication, and you are going to see the law of excluded middle in mathematics, which the notable person there is Aristotle. In 1951, Stephanie Lupasco brought about the third option, and Aristotle said there is no third option, and that is what we are using now in quantum mechanics. The same Aristotle, when Galileo said light objects and heavy objects will fall under the force of gravity at the same time, he said no. He made them to stone Galileo to death, and now that is what we are using. So, but no problem. Let's say what we call implication. Implication. That is implication truth table. I will say implication, the symbol is this. The symbol is this or this, in case you see it anywhere. In case you see it anywhere. Okay. So in implication, we'll have P, right? Then normally Q, the same way, this implication truth table. But in this case, we are not going to put this again, 1 plus 1, and this is what P implies Q. Good. So in this case, if this is true and this is true, this is true. Let me give an example. If you take first position, I'll give you 1 million. You took first position, I kept to my promise, and I gave you 1 million. That means it's true. P is the hypothesis, the antecedent, and Q is the solution. P implies Q. P is sufficient for Q. Q depends on P. So You took first position, I gave you 1 million, is true. Now, what if this is true, that you took first position and I did not give you 1 million? So what do we do? You took first position, I did not give you 1 million. It's false. That means what I said is not true. It's false. In this case, we are not using this one, no, the plus and this. So what if this is false? And this is what? True. You not take first position and I gave you 1 million. I gave you 1 million, you not take first position. So in this area, what we do in this area is that it's true, because this area is using what we call two-valued logic. Two-valued logic. Two-valued logic is what we use here, right? So now in this area is what we said, the law of excluded middle. So what if this is false and this is true? Yes, this is false, not true. So what do? You not take first position and not give you 1 million. That means it's true, because we say that this implies this. So in this case, we are going to use this very well in other examples, in a live example, and you understand better. So we introduce what we call by implication. By implication. By implication. I will say the symbol is like this. So in this area, what we do here is we have P, Q, same way. Let me draw it in a place that is big for you to see. The place that is big, so you can see it very well. That is by implication. By implication. Sorry. So in this case, we have one the same way. Good. We said this is by implication. By implication. I will say the symbol is this or this, right? Or this. So that means this, this. What this means is that if and only if, for example, Ben will do well in exam if and only if the school is good. That means Ben will do well if and only if the school is good. It is true. What if this is true, the school is good, and Ben didn't do well? That means it's false, because this is the implication is telling us that Ben will do well if and only if the school is good, and the school is good, Ben did not do well. That means it's false. Good. Now what if this is false and this is true, that the school is not good but Ben did well? That's not what the law says. We say that this Q depends on P, P depends on Q, if and only if. So any other thing that is outside this will not be okay with us. So The school is not good and Ben did well. It's a lie. So it's false. Now, what if this is false and this is false? That the school is not good and Ben did not do well. That means it's true. Because we said that Ben can only do well if and only if the school is good. So if the school is not good, that means Ben will not do well. So the answer here is true. Because that's what we said. The school is not good, Ben did not do well. It's true. So this is where we'll stop today. Then in our subsequent class, we'll do further operations. But let me tell you one thing, logic is very good because it increases your problem solving skills. In quantum mechanics, as they're saying, we're going to see the implication of this third person. And how? So that is logic. Thank you so much.